Hello everyone, welcome to the class. Today's class will be talking about questions which can appear in your JEE main examination on the chapter Laws of Motion. Now in JEE main examination the questions are single objective type, so you have to choose one option as the correct option. So these questions that I'm going to discuss today, some of them are actually asked in the previous JEE main examinations in Laws of Motion chapter. So let's go ahead and let's see what kind of questions do appear in your Laws of Motion chapter in your JEE main examination. Let's see here. The first one. A bullet of mass 0.04 kg moving with a speed of 90 meter per second enters a heavy wooden block and is stopped after a distance of 60 centimeter. What is the average force exerted by the block on the bullet? A minus 270, B minus 330, C minus 430, D minus 510 Newton. So let's see what is the force. Now see, we know that force equal to mass into acceleration. The wooden block is going to exert a force on the bullet along the opposite direction. So if I go ahead, if I write down the D acceleration that will be created on the bullet due to the wooden block, that will be, now see that, its final velocity is 0, its initial velocity with which it was moving, that is given as with a speed of 90 meter per second. So that is the initial speed, so 90 meter per second. The distance that it has covered within the wooden block, that is given as 60 centimeter. So it has covered a distance of 60 centimeter within the wooden block. This 60 centimeter can be written as 0.6 meters. Now if we use V square is equal to U square plus 2AS. U is 0, so we'll be having, let's put up the values directly, sorry, V is 0, so this is 0, U is 90, so 90 whole square plus 2A. So A I'm putting as it is and S is 0.6. This is the value that you're going to get. So A will turn out to be minus of 90 whole square divided by 2 into 0.6, that is 1.2. 90 whole square divided by 1.2. So if we open this, we are going to get minus 8100 divided by 1.2. The same can be estimated. So acceleration is actually negative of 8100 divided by 1.2. This is what the D acceleration that we are obtaining. Now the force exerted by the wooden block. Let's go ahead. The force exerted by wooden block is simply mass into acceleration. Mass is given as 0.04 kg. You can see that mass is 0.04 kg. Let's go ahead. 0.04 multiplied with 8100 divided by 1.2 and it's negative. You can easily evaluate this. Now see, 0.04 and 1.2 that can be divided, so you'll be obtaining, if I directly do this, I'll be having 8100 divided by 0.04, it will go, this will come 4, this will come 120, this will go 30 times, and then easily you can see the resultant answer 810 by 3, that will come out to be minus 270 Newton. Quite easily we have evaluated. So the right answer for this question turns out to be minus 270 Newton. That means a force that is trying to retard the bullet will be exerted on the bullet due to the wooden block. So we got the option number A as the right answer. Let's go ahead with the next question of the class. Let me just clear the board for you all. And let's be very quick to do the next question. The first question was quite easy. Such simple questions can also come in your JEE main examination. Let's go ahead for the next question. Second question, a body of mass 100 kg stands on a spring weighing machine inside a lift. The lift starts to ascend with an acceleration of 2.2 meter per square second. So with acceleration of 2.2 meter per square second, first important point that we should keep in mind that the acceleration of the lift is 2.2 meter per square second. What is the reading of the machine? A 600 Newton, B 1200 Newton, C 1400 Newton, D 1500 Newton. Now you must be remembering about the G effective. Let me tell you how to solve this question. First of all, if the weighing machine is kept static and the man stands here, it weighs the weight of the man. Now see, the man is attracted with a force mg. And this, the normal reaction produced by this swaying balance will be actually the weight of the man. So we normally what we do N equals to mg. Now here, since it was static, it was not in motion, so directly we did N equals to mg. But whenever the lift is in acceleration either upward or downward, then what we need to do, we need to use, I'm going to tell you a method, what method you have to apply whenever it moves with an acceleration. Remember, the force due to the gravity of earth will be mg. That will be the same. But the weighing balance actually checks the normal reaction provided by the weighing balance. What will be the G effective of this system? If we take this is actually enclosed in a lift. This lift is moving with an acceleration. It's given that it has got an acceleration in the upward direction as A. That is 2.2 meter per square second. We'll go ahead with that. Now, first of all, let me tell you, the normal reaction will be equal to m into G effective. Understand first this. It will be m into G effective. Now, I have used a term G effective. That is the effective G that is actually acting on this man. That will turn out to be the formula I have already told you all. G effective is vector G minus vector A. Try to understand. Now, vector G, that is the extent due to gravity, that's acting downward. That will be 9.8 minus, now see, acceleration of the lift, it's moving along the upward direction with an acceleration of 2.2. Put it value. Now, upward direction will automatically become negative because we have taken downward direction as positive. So, this will be written as minus 2.2, comes out to be 12 meter per square second. This is the effective value of G. So, we got the effective value of G that will be acting, that will be working on this man, that will be 12 meter per square second along the downward direction. So, normal reaction will be just, the magnitude will be same as mg effective. So, we need to write normal reaction as m into G effective. Mass is provided. Let's see, the mass is given as 100 kg. You all can see this. Mass is 100 kg. So, let me substitute here mass 100. G effective is 12, so it turns out to be 1200 Newton. The right answer is 1200 Newton. So let's see the option. The options are which matches, that is option of B, that is 1200 Newton. So 1200 Newton is the right answer for this question. Let's go ahead with the next one. Let's go ahead with the next one that we have. Next question of the day, we have question number 3. A block of mass small m is at rest under the action of force capital F against a wall as shown in figure. Which of the following statements is incorrect? We need to find out which statement is actually incorrect regarding option number A, small f is equal to mg, where F is the frictional force. So see here, given frictional force in terms of small f, we should know that it is given as mg. Next, capital F is equal to N. The capital F that is acting is equal to N, where N is the normal force, normal reaction acting on the block. Capital F will not produce torque. Let's see whether capital F will produce torque or not. Now, small option number D, N will not produce torque. So we got this. Capital F will not produce torque, N will not produce torque. We got these options. Now let me show you a free body diagram of this block, which forces are acting on this block due to the wall and rest other things. Now see, this block is actually attached to this wall. This is the block and the mass is given as small m. The force that is acting towards the wall, that is given as capital F. Now there will be a normal reaction acting on the block, and this normal reaction will be along this sense. Let me show you that this normal reaction is acting on this block along this direction. So from the horizontal equilibrium, we can easily write that F should be equal to N. Horizontal equilibrium, F should be equal to N. Now let's talk about vertical forces. Now understand, mg is acting along the downward direction. To balance it, since it is in equilibrium, the frictional force has to act along the upward direction. So I have marked F. So for vertical equilibrium, small f should be equal to mg. Now understand the torque about the point that is center of mass. that will be due to frictional force and normal reaction. Try to understand the torque about the center of mass that will be due to frictional force and due to normal reaction. So what I'm going to do, I'm going to mark net torque. Torque about center of mass will be equal to torque due to frictional force plus torque due to normal reaction. That means there's a torque due to frictional force. There's a torque due to normal reaction. Now let's see the options. Let's check the options. F is equal to mg. Yes, we have already evaluated F is equal to n. I have written, and sorry, F small f is equal to mg, that we have written. So yes, this option is right. So we need not to tick it because we want incorrect options. Capital F is equal to n. We written capital F is equal to n. So this is also right. So don't tick this as the answer. C, F will not produce torque. Capital F. Capital F is acting along the center of mass, so it's not going to produce any torque. So this is also true. So need not to mark this as the right option. Option number D, you check. Capital N will not produce torque. That is the normal reaction. But we know that. Now see, torque about this point. Let's see this equation. Torque about C comes out to be 0. That means torque due to F should be equal to minus of torque due to N. Both will be having torque. That means there will be some torque due to normal reaction. That means N will not produce torque is the incorrect statement. Hence, you have to mark this as the answer. This is a previous year question. It's a very important question. People will get confused which option to tick. The first two options are quite obvious that they are right. But people will get confused in these two options. These two options will actually make you confused which one to choose. Which one is the incorrect option. So you have to frame equations. You have to see what is happening. That's why I have talked about the torque about the point that is center of mass of the block. Then like this you have to do. People who are unaware about the torque, I have told you about the moment of force. That is what I am talking about. And I have given you an introduction about torque. That is what you have to use. I hope that you have understood how we need to solve such kind of questions that we are having here. Next one. Let me just clear up the board and we'll start the next one. Next question of the class we have as question number 4. The pulleys and strings shown in the figure are smooth and of negligible mass. For the system to remain in equilibrium, the angle theta should be A 0 degree, B 30 degree, C 45, D 60. I believe that you all can visualize this diagram. If not, don't worry, I will also draw the diagram. There's a pulley, two pulleys given here. One mass of mass m, one actually block of mass m is hanging. Another block of mass m is hanging here. Then we have a string actually continues from both the ends, and we can see that a block of mass root 2 m is hanging. The angle that these strings make with the vertical, that is given as theta. You see this is theta. Let me just show it completely that this is theta. Now let me draw the diagram separately for your better understanding. This is how it is represented. So we have two pulleys. We have strings passing over the pulley. That is what I am doing here. I am attaching the two pulleys here. This mass is given as root 2m. Then we have another block here. We have another block here. So I have drawn the diagram. Now you will see here, if I show you that this angle is theta. Now see, the string is uniform, it's light, inextensible, that is what has been given. The tension developed in the string will be same. So that means if the tension is T here, so it will be T here, and due to symmetry, everywhere the tension will be same as T and T. Now try to visualize. First of all, let's make a free body diagram of this block. I am marking this block as A and this block as B. For free body diagram of A, if I draw FBD of A, I'll be having this block of mass m, force due to earth acting as mg, tension in the string that is T. So we easily obtain that tension will be equal to mg. Equation number 1 obtained. If we make FBD of this block B, everyone look here. If we make FBD of block B, so we have an object of mass root 2m. The forces acting on this is root 2 mg. two tensions acting along two different directions, T and T. This is the angle theta that it makes with the vertical. For vertical equilibrium, we will be having T cos theta and T cos theta will add up and it will balance this weight. So we will be having 2T cos theta is equal to root 2 mg. Equation number 2. 2T cos theta is equal to root 2 mg, and here we have T equals to mg. If we divide equation number 2 by 1, we will be obtaining 2T will be left with 2T, sorry, 2 cos theta will be left with, and then we will be having this is equal to root 2. This is what we will be obtaining. So finally cos theta will come out to be 1 by root 2. I believe that you all must be remembering what is the value of cos, for which angle cos theta is 1 by root 2. It's quite obvious, theta will turn out to 45 degree. Let us go ahead, check the options. Theta, C option, 45 degree. Previous year question, quite simple. And if you know how to resolve forces, you can easily score valuable marks in your JEE main examination. Let's go ahead. Now with all such kind of questions, we actually get to know the feeling that a student has for JEE main examination, that it's a tough examination. No, it's not tough, and actually you should have the knowledge, you should have the practice. You can easily score good marks in your JEE main examination. That's countable, and you can bank upon if you know more concepts and knowledge, more practice. Certainly that's going to help you to get good ranks. Next question. Question number 5. A string of negligible mass going over a clamped pulley of mass small m supports a block of mass capital M shown in the figure. The force on the pulley by the clamp is given by. So see here what forces we are having. You see, a string of negligible mass going over a clamped pulley of mass m. So pulley mass is given as a small m, supports a block of mass capital M. So here we have a block of mass capital M that has been given as shown in figure. The force on the pulley by the clamp. So we need to find out what's the force acting on the pulley by the plank. Let me draw the diagram once again. For your better understanding, we have a pulley, we have a string tied to it, we have a block hanging. The pulley mass is given as a small m. Let me show it separately, that pulley mass is given as a small m. We need to find out what is the force acting due to the clamp of the pulley. This is what we have to find out. This pulley is of mass m. Try to understand. First of all, there will be a tension that will be generated, that will be created within the string. So I am marking this as the tension. Capital M, small m, two masses are given. The weight acting along the downward direction is mg. The tension acting is T. So what we can write? We can write tension T is equal to mg. On the pulley, you see what forces are acting. If I make the free body diagram of pulley, you see the forces that are acting. Now you see one force is acting, tension T is equal to mg along this direction, sorry, capital Mg. So I need not to mention small mg, that should be capital Mg. And along the left hand direction, we will be having again one tension, that is capital Mg. Capital Mg here due to tension, and again due to this part also capital T you should be having, that is the force acting on the two directions. Mg force will be also acting along the downward direction due to the mass of pulley. So what I am going to show you all, I am going to show you that small mg force should be also acting on the pulley. The clamp is going to balance the resultant of these three forces. The resultant of these three forces will come out to be F resultant. That will be equal to under root of two forces acting on this direction, mg plus mg. So this will be m plus m g and whole square plus mg whole square. This is what the resultant force that will be acting on this system. Now you try to understand, we need to find the force on the pulley by the clamp. If we compare, now if I simplify this, I will be obtaining g whole square can be taken as common and will come out. We will be having under root m plus m whole square plus capital M whole square. This will be the value of resultant force acting on the pulley by the clamp. The force on the pulley by the clamp is given by option number C. If you see, option number C actually, no, it's option number D, because here we have capital M. So option number D matches, so D is the right answer. I believe that you can clearly see. And already I have written the same option at the other end of the board also, and hope you have noted down that. So option number D is the right answer, so you should have understood how to solve such kind of questions. Let's proceed. It was good question. Right now I am solving very fast, but when you solve it on your own, you'll find that it will take time for you all if you are in lack of practice. And if you have practiced enough, then that will be well and good for you all to solve such questions, and you can do very easily. Question number 6 that we have, given in the figure are two blocks A and B. So we have two blocks A and B. I will draw also a big diagram also, don't worry, of weight 20 Newton and 100 Newton respectively. These are being pressed against a wall by a force capital F. So a force is actually pressing these two blocks as shown in figure. If the coefficient of friction between the block is 0.1, if the coefficient of friction between the block is 0.1 and between the block B and the wall is 0.15. So between blocks it's 0.1 and between wall and B is 0.15. The frictional force applied by the wall on the block B. It's in block B, that's not, it should be on block B. Now let's try to understand what is this figure showing us. Let's go ahead. I will draw the figure for you all. We have two blocks A. It's given that its weight is 20 Newton. That's acting on this. Now there is a force F acting. Now we have here R, it's provided, it's given here F1 acting on this block. Then it's again given that this is R, this is B. Its weight is acting along the downward direction. That is given as 100 Newton. The more options, it's given as F1 is acting along this sense, along this direction. And then we have R acting here. Then we have F2 acting along this direction. This is what we have been provided. We want to evaluate F2 value. The frictional force applied by the wall on the block B. So we need to find out what is the value of this F2. Check here. We need to find out what is the value of F2. That is frictional force on block B due to the wall. I hope that that point is clear to you all. Let's go ahead. First of all, you see, for vertical equilibrium of block A, understand, for vertical equilibrium of block A, we can easily mention that F1 should be equal to WA, it should be equal to 20 Newton. So we got the value of F1, 20 Newton. Let's talk about the vertical equilibrium of block B. For the vertical equilibrium of block B, you see here F1 and WB are acting along the downward direction. F1 and WB, and F2 is acting along the vertically upward direction. So what I'm going to write, I'm going to mark F2 is acting along upward direction, that should be equal to F1 plus WB, that will turn out to be F2. We need to evaluate. F1 we got 20, WB is 100 Newton. So I'm going to put up the values 20 plus 100, easily evaluated 120 Newton. The problem that in this question student thinks, they think that how to approach what is given in this diagram, we are getting complicated. It's a previous year question, how to find out the resultant answer. But stepwise, if you see stepwise how you will proceed with the first block, then towards the second block, you will get the answer. The right answer is option number B, that's given as 120 Newton. Option B is the right answer for this question. Before proceeding to the next one, let us go ahead and let me just clear the board for you all for the next one. So let's go ahead with the next problem that we have. Question number 7. A block of mass small m. A block of mass small m is placed on a surface with vertical cross section given by y equals to x cubed by 6. If the coefficient of friction is 0.5, the maximum height above the ground at which the block can be placed without slipping is A 1 by 6 meter, B 2 by 3 meter, C 1 by 3 meter, and D 1 by 2 meter. So let's see the scenario of the question. I need to make a diagram to make you understand. What I want from you all, read the question once again. When you read, you will find that it's given that it's along a curve. The vertical cross section, that is y equals to x cubed by 6. Now check the coefficient of friction, the surface that provides on the block, that is 0.5. That is the value of coefficient of friction provided. Now try to understand on your own. As we keep the block on this surface, it will slip. But if we have kept it at a particular height, but we have to find out the range of this height where this block will not slip. So first of all, we have to find the maximum height above the ground at which the block can be placed without slipping. I will show you in a diagrammatic way how to do such kind of question. First of all, it's given that y equals to x cubed by 6 along such a, let's say this line is it follows the equation y equals to x cubed by 6. The block is kept here. Let's say when it is placed here, it will not slip. And now if I find out the value of tan theta, if I say this is theta, I have actually drawn a tangent. I have drawn a tangent here. Now if I write down the value of tan theta you all must be knowing that is dy by dx. First thing, y equals to x cubed by 6. So we need to do d by dx x cubed by 6. Easily you can evaluate this. See what kind of questions actually the JEE examiner actually seeks from us. D by dx x cubed by 6, that will come out with 3x square by 6. It will be x square by 2. You can easily check, it will be x square by 2. This is what the resultant answer that you will be obtaining. Now if I proceed from here, we got the value of this tan theta, that this line will make a slope for the curved slope at this point. Now let us know the limiting value of the friction. For limiting value, if you talk about, mu is equal to, at limiting friction, when maximum friction acts, we all have learned this, mu is equal to tan theta. So we need to avoid it slipping. So mu that is given as 0.5. So I'm going to put mu as 0.5. So if I write here mu as 0.5, I will be writing tan theta is equal to x square by 2. From here you see x will come out to be plus minus 1. 2 into 1.5, that will give you 1, x will come out to plus minus 1. When x equal to 1, when x equal to plus 1, so y will be simply x cubed by 6, 1 by 6. When x is equal to minus 1, sorry I wrote minus 6, that's minus 1, y will turn out to be minus 1 by 6. Minus 1 by 6 is not a possibility, the only possibility is y equals to 1 by 6. So at a height of, what is y? Y is actually giving us a height. At a height of 1 by 6 meter, the body is not going to slip. Once again, I will just repeat it for you all. Draw the curve, find the slope at any particular point. The slope will be given as this. Then you are going to have this x square by 2. Put up the values for the slope, for the limiting value. Mu equals to tan theta, so you will be obtaining this 0.5 is equal to x square by 2. I hope that is clear to you all. Then x will come out to plus minus 1. Put the value, get the two values of y. Find out for which value of y you are going to have the right result. So I want you all to take note till here, and I will start from the other end. Take note till here. Okay, I believe that you would have taken note of this part, this question. This was a very interesting question, and let me tell you, such kind of questions do appear in JEE examination. People actually don't get the idea how to approach. This time the surface equation was given as y equals to x cubed by 6. Sometimes a parabolic equation can be provided to you. A different kind of parabolic with lot of variables can be provided to you. So you should understand what you have to apply. First of all, you find out the slope at any particular point, equate it to the limiting value of friction force that we have done, that it should be equal to mu equals to tan theta for limiting friction. Then go ahead, relate, find out one variable x value. From it, put up this value in the equation, you are going to obtain the value of y. two values we got, you have to understand, you have to apply your own logic, which value to eliminate and which value to use. So you got y equals to 1 by 6, and don't worry, minus 1 by 6 is not provided also in the option, so need not to worry. So the right answer, if you see the option, the right answer is given as option number A, that is 1 by 6 meter, that is the right answer. So before proceeding to the next question, let me show you all the next question. This question number 8. Just have a look on it and let me clear the board for you all. Okay, I believe that you would have read the question number 8, and I believe that you would have clearly understood all the 7 questions that we have just now did. Now question number 8, just read the question once again with me. What is the maximum value of the force F such that the block shown in the arrangement does not move? We have a figure, we need to find out what is the maximum value of this force F such that this block, its mass is given as root 3 kg. It's given m root 3 kg. F is applied making an angle of 60 degree with the horizontal. The coefficient of friction between the ground and the block is mu equals to 1 upon 2 root 3. We need to find out what is the maximum value of this force that we can apply so that the block will not move. Block shown in arrangement does not move. Now option number A 20 Newton, B 10 Newton, C 12 Newton, D 15 Newton. Let's try to find out what will be the best option that will be suiting to this question. Now see, I will draw the free body diagram of this block. How it would look like? See here, we have this block, and let me show you the force that is acting on this block. The force that is applied making an angle of 60 degree with the horizontal. So we'll continue with this. This is the force applied, 60 degree with the horizontal. The coefficient of friction between the block and the ground is given as mu is equal to 1 upon 2 root 3. The mass of the block is given as root 3 kg. All this information has been provided to us. Now let's try to sort out, let's try to make the forces in what direction it is acting. Now see, its component F cos 60 degree will act along the horizontal direction, and its component F sin 60 degree will be acting along the vertical downward direction. So if I show you the forces, and if I draw the same block diagram here, if I draw a free body diagram here, you see here, let me show you the forces that is acting on this block. This is the block, mg is acting along the downward direction, and also F sin 60 degree is also acting along the downward direction. Normal reaction will be acting along the upward direction. Now you see the horizontal direction force that will be acting. First of all, F cos 60 would try to move it along the forward direction. Now the friction force that is acting, that will be acting just opposite, that will be small f. I am marking it with small f. This is the block that I have shown you here. This is all the forces we have depicted here. The body is not moving, that means the body is in equilibrium. That means we can actually equate the forces acting along the horizontal to be 0 and forces along the vertical also to be 0. Now first of all, you see, if I write the equation for the vertical, along the vertical, how will it look like? We can easily show that N will be equal to mg plus F sin 60 degree. First thing we obtained. This is for the forces, equating forces along the vertical direction. Now equating forces along the horizontal direction, it's a case of limiting friction. Then we should have, since body is not moving, F should be greater than or equal to F cos 60 degree. The friction force should be greater than or equal to F cos 60 degree. Now quite obvious for us to understand that since we are talking about limiting friction case, so we can write, we'll actually equate this to equal to mu into N, because we are talking about the limiting friction case. Now you see here, mu into N, N is mg plus F sin 60 degree. Mu into mg plus F sin 60 degree. This will be greater than or equal to F cos 60 degree. So we obtained till here. Now we have to only put up the values. Everything is quite clear with us, to us. See, mu value is 1 upon 2 root 3. So let me put here 1 upon 2 root 3. M is root 3 into g plus F. We have to evaluate. Sin 60 is root 3 by 2 is greater than or equal to F cos 60, that is F by 2. Now just multiply this term with the inside of the bracket, all the terms, see what we will be getting. Let me rub this diagram. Now you see, if I multiply 1 upon 2 root 3 into root 3. Root 3 will be cancelled out. Again, this term is multiplied here. Root 3 will be cancelled out. So, we will be obtaining 1 upon 2. So, g by 2. So, we will be obtaining g by 2 plus, see here again, once again, root 3 will be cancelled out. 1 upon 2 multiplied 1 upon 2, 1 upon 4. So, plus f by 4. Plus f by 4. This entire term should be greater than or equal to f by 2. So, we will be having g by 2 should be greater than or equal to f by 4, and then f should be greater than or equal to 2g. Sorry, f should be less than or equal to 2g. Easily we can see that. So, f should be less than or equal to 20 Newton. So, the maximum value of force that can be possible for not moving the block, that will be 20 Newton. This is how we have to reach on this step. We have to equate the force along the horizontal and along the vertical. This is one of the questions which is asked in previous examination. So, option number A is the right answer. That is 20 Newton is the right answer for this question. Let's go ahead. I believe that the explanation and would be clear to you all, and you would have understood how to solve such kind of question. The next one, the next question of the day we have question number 9. Look here, the statement, long statement, a diagram. An insect crawls up a hemispherical surface very slowly. See the figure, we have a figure, an insect crawls up hemispherical surface. The coefficient of friction between the surface and the insect is 1 by 3. If the line joining the center of the hemispherical surface to the insect makes an angle alpha with the vertical, the maximum value of alpha is given by. Now see, it climbs slowly. This thing we need to consider, it climbs very slowly. Mu is given as 1 by 3. Now the maximum value of alpha that is possible, we are talking about limiting friction case. Now see here, A cot alpha equals to 3, B tan alpha equals to 3, C sec alpha equals to 3, D cosec alpha equals to 3. Let's try to find out. I will draw a diagram once again. You see here, this is the case. This is the hemispherical surface. We have an insect. Let's say the insect is somewhere here. This is the insect as I have shown you here. This is the center of the sphere of which it is a part. And let me join this line. Let me join this line. Now see the forces that will be acting. One will be normal, quite clear. This is alpha, quite clear to us. Now mg is acting along the downward direction. Mg quite obvious, that is the weight of the insect. Its mass we have taken as m, and its g we have multiplied to note that its weight is acting along this direction. Now you see here, this angle alpha, we can say this angle is alpha. So n will be having two components. One will be n cos alpha, easily we can make out, and one will be n sin alpha. We can easily make out. This is what we can actually break up the forces for n. I want you to take note of this diagram. I will start at the other end. Okay, I believe that you have taken out the diagram. Now see, the beauty of the question is this. Why I showed you that forces can be resolved along this direction. Most of the students will actually depict the forces and will resolve along this direction as I have shown you here. But you see here, it's asked what is the maximum value of alpha. As it moves, mg component will try to bring it down, and friction will try to resist it. Friction will try to avoid it slipping. So we need to resolve mg. We should not resolve n here. So I'll make the change. Don't do this error. Don't do this mistake. So let me show you the exactly how the forces should be resolved for this problem. Again, this was the insect. This was the center. We have joined this line, and this is the line joining the center. This is the normal reaction that is acting. So resolve, you have to resolve mg. Don't resolve normal. This is the mistake that often students do. So mg, now see, if I find this, we will find that this is alpha. Now see, mg component that will be acting just opposite to normal, that will be mg cos alpha, and mg component tangentially will be acting, that will be mg sin alpha. I believe that this should be clear to you all. Now see here, for its equilibrium along this direction, we will be having n should be equal to mg cos alpha. So let me write N should be equal to mg cos alpha. Next thing you see here, friction force will try to avoid it slipping, and the maximum value of friction force we need to talk about. So what I'm going to write, F is equal to mg sin alpha. So let me write F as, because we are talking about limiting friction, limiting case, so that's why directly I have put F is equal to mu into N. Otherwise we cannot put F is equal to mu into N. Mu into N equals to mg sin alpha. Now let me take this as equation number 1. Equation number 2, let us divide 1 by 2, N divided by mu, so we'll be having 1 by mu is equal to, you see here, cos alpha by sin alpha, you'll get cot alpha. Mu, the value of mu that has been given, that is 1 by 3, so cot alpha will turn out to be equal to 3. The right option that matches with the right answer, that is option number A. So take the option number A, you'll get the full marks for this question. Again, this is a previous year question. You should know how to solve such question when insect crawls up. Resolve mg, remember this. So in different cases you have to resolve sometime normal reaction and sometime mg. Here mg was resolved. If the hemispherical surface was actually rotating, then we need to resolve normal reaction. That will depend upon case to case, we will see that later on. 10th question. A piece of wire is bent in the shape of parabola, y equals to kx square, y-axis vertical, with a bead of mass m on it. The bead can slide on the wire without friction. It stays at the lowest point of the parabola when the wire is at rest. The wire is now accelerated parallel to the x-axis with a constant acceleration a. The distance of the new equilibrium position of the bead, where the bead can stay at rest with respect to the wire from the y-axis. I believe that you would have read the question, you would have understood the each point that the question is pointing to us. Option number A by gk, B, A by 2 gk, C, 2a by gk, and D, A by 4 gk. K is a constant used and G is the extent due to gravity that is actually acting here. Now see here, let me show you the figure first of all, what's happening in this case. This is the case, we have y equals to kx square. Now first the bead was at rest, the bead was here, try to understand. The bead was at rest at the lowest point of the parabola. Now when it starts moving with an acceleration a, the bead actually moved up. Let's say this is the point where bead moved up. I've used one time the purple color, so let me use it. So bead moved here, let us say here. Now you see here the acceleration on this bead that is acting, that would be a. Now try to find out the slope of the curve at any of the point, at this point. So if I draw a tangent to this point, it will be somewhat like this. Now you see here how we can proceed. If I draw a normal at this point, this will be the case. This will be the normal reaction that will be acting on this block. So we need to resolve the forces. Now let's read this statement of the question. Given the equation of the curve, that is y equals to kx square. Now bead mass is m. The bead can slide on the wire without friction. No friction is there. It stays at the lowest point of the parabola when the wire is at rest. The wire is now accelerated parallel to x-axis with a constant acceleration a. The distance of the new equilibrium position of the bead, where the bead can stay at rest with respect to the wire. Now you see here, given that y equals to kx square, this is the curve's equation. So if I differentiate this, dy by dx, so we can write this as 2kx. dy by dx to 2kx. What is dy by dx that is giving to us? That is the angle that this line makes with the x-axis. And here you can take this as the angle theta that I am talking about. So dy by dx, that is the tan theta, is 2kx first of all. So what do you take note till here, and let me start from the other part. Take note till here. So I believe that you have taken note of this diagram. Now see here, I have shown n is acting here. In this case we have to resolve normal reaction. So what we will do, we will be resolving normal reaction. Normal reaction component will be acting on the vertical direction, If its mass is m, you see here if its mass is m, so mg will be acting along the downward direction and ma should act, the net force should act along this direction. Let us say this angle will be quite obvious, it will be 90 minus theta. If we have taken this as theta, this will be 90 minus theta. Let us take 90 minus theta equals to alpha for our reference. We can take this equals to alpha. So we can write n cos alpha equals to ma. N cos alpha is equal to ma and n sin alpha is equal to mg. N sin alpha is equal to mg. Now if you see here, n cos alpha and n sin alpha we have, so we can write, if we divide this n by this, n cos alpha divided by n sin alpha, we will be having cot alpha is equal to a by g. That means cot 90 minus theta will be equal to a by g. Quite obvious. We have taken this as theta, don't worry. This will be this and this angle will be complementary to each other, that you can check easily. Now cot 90 minus theta is what? Tan theta is equal to a by g. We got this. Tan theta equals to a by g. We can put dy by dx equal to tan theta. That will come out to be, instead of dy by dx, that is equal to tan theta. Now dy by dx we can put as a by g, and tan theta we can put as 2kx, that is dy by dx is 2kx. So from here x comes out to be a by 2kg. So we got the answer x equal to a by 2kg, that is 2gk. So option B matches with our response. This is how you have to solve such kind of question. This was a very interesting question, previous year question. This is how you have to approach. You have to resolve the forces and then you will be obtaining the right answer. So after all this questions practice, I believe that you can easily go ahead and solve previous year question and question based upon JEE main examination. So I wish you all the very best. I'll meet you in the next class with more illustrations. Thank you everyone.